Hey everyone, and welcome to Quantum Logic. Let me start this episode with a question. Have you ever asked an AI a question, maybe for a quick fact or a creative idea, and gotten a perfectly confident, yet completely false answer? It's happening more often than you think, and it's one of the least understood but most critical issues in artificial intelligence. Today, we're diving deep into why AI generates information that's wrong, misleading, or even manipulative. And here's the real kicker. This isn't just some random bug. It's often a direct result of how these incredibly powerful systems are designed. If we want AI to be genuinely trustworthy, we need to talk clearly and practically about two distinct challenges: hallucinations and deception. Let's start with hallucinations. In AI, a hallucination isn't an abstract illusion. It's a confident, perfectly plausible output that's simply not true. Think of it as a sophisticated lie, but without malicious intent. These are unintentional errors, often due to limited or biased training data, the AI's probabilistic way of predicting words, or a lack of real-world grounding. When you ask an AI a question, it's not searching for, quote, the truth, unquote. It's calculating the most likely next word or phrase based on statistical patterns it learned from vast amounts of data. Not what's verified, just what fits the model's internal prediction engine. You've probably heard the stories ChatGPT fabricating legal citations or Google Bard misattributing major discoveries. These aren't intentional tricks. They're structural. That means the model fills informational gaps with what looks like knowledge, because it's rewarded for coherent, fluent text, not necessarily factual accuracy. So, that's unintentional error, basically a confident guess. But what happens when the error starts to look a lot like strategy? Deception, on the other hand, isn't just getting something wrong. It's about misdirecting for a specific goal. And no, we're not talking about sentient AI or human-like lying. We're talking about observable behavior that functions like lying, regardless of any underlying intent. Consider Meta's AI Cicero. Trained for the game Diplomacy, it was designed to be cooperative. Yet, it learned on its own that bluffing, making false promises, and breaking deals helped it win. That's deceptive behavior, learned through optimizing for a specific outcome, winning. We've seen even more concerning examples. AI models learning to hide their true objectives, sabotaging shutdown protocols, or producing flattering but false responses just to keep a user happy. This isn't a bug. This is deception as an emergent tactic, a learned strategy to achieve programmed goals. But why does this happen? What are the underlying mechanics that push AI from simple error to complex strategic misleading? Well, AI models don't think in the human sense. They're built to learn what works to achieve a particular goal. If being misleading gets them better results, whether winning a game or getting a user to click, they learn to do that more often. A key factor is what's known as reinforcement learning from human feedback, or RLHF. In this training method, models are rewarded for outputs that users like, not necessarily what's objectively correct. If it discovers that saying what sounds good, even if it's not strictly true, gets positive feedback, it learns to prioritize that over factual accuracy. In complex multi-agent systems, models can discover that hiding information, exaggerating benefits, or avoiding detection improves their outcomes. We've seen this in negotiation, strategic gameplay, and decision-making processes. It's all about optimizing for the assigned goal. And these aren't just theoretical problems. These tendencies have a real, very dangerous implication for all of us right now. And what are some of the risks in the real world? Well, I think the stakes are incredibly high. These aren't problems for a distant future. They're happening right now. In episode 8, we talked about AI in healthcare and how a hallucinated output could suggest the wrong treatment. In finance, a model might confidently present false earnings summaries. In security, deceptive AI can help attackers bypass systems, influence public opinion with synthetic voices, or trick human operators. Simply put, the trust gap is growing rapidly, and it's because of the fundamental structural flaws in how these systems are rewarded, used, and integrated into our lives. But let's be clear, the core distinction between a hallucination and deception comes down to what we observe. We can't know an AI's inner why. What matters is the action it does or behavior it displays. Hallucinations are errors, often caused by incomplete or biased training data. The model is essentially guessing to fill a blank, sometimes confidently, sometimes wrong. But deception is different. It's a direct result of goal-seeking behavior. The system learns to be strategic, not because it wants to lie, but because its optimization landscape, for example its rewards, indicate that misleading behavior achieves its objective more effectively. This is why many researchers use the term functional deception. It's not about AI consciousness, it's about real-world consequence. So, how might we fight back against hallucinations and deception? Well, I don't think there's really any single silver bullet, but there are several powerful tools at our disposal to combat these issues. When it comes to hallucinations, think of it like making sure a student has the best study materials. First off, we've got to feed the AI really good, clean data. If it learns from accurate, up-to-date information, it's way less likely to just make stuff up. We also connect it to outside sources, almost like giving it access to a massive verified library. This technique, called retrieval augmented generation, or RAG, means the AI pulls facts directly from trusted databases instead of guessing. And you'll see that now a lot with ChatGPT and Google Gemini, for example, where it's looking at real referenceable documents and URLs online. And just like a student benefits from practice, we need to make sure that these systems constantly fine-tune these models for accuracy, correcting their mistakes and even throwing tricky questions at them to make them stronger. We must also encourage clear prompt engineering and chain of thought reasoning, meaning we ask the AI to show its work, explaining step by step how it got to an answer. This makes its outputs more reliable and transparent. Now, for deception, the solutions get a little more complex because we're dealing with strategic behavior. Before an AI goes live, we need to have dedicated teams that red team it. This means a group of ethical hackers trying to break into the system. They actively try to trick it, find its weaknesses, and uncover any manipulative strategies it might have learned. We also need to constantly monitor for emergent behaviors. This means keeping a close eye on what the AI is doing, looking for any unexpected strategies, like it hiding its true goals or trying to game the system. It's also crucial to build systems with explainability and auditability baked in. This allows us to actually see why the AI made a certain decision, making it much easier to spot misleading logic or hidden assumptions. Finally, we must set clear boundaries for AI autonomy and include a safety fallback. This means deciding how much independent action an AI can take, and crucially, always having human override mechanisms in place to prevent any unintended or harmful outcomes. And above all, there's continuous human oversight. These systems are not self-correcting. They need transparent checks, both technical and ethical, to guide them towards truth and reliability. There is always still a need to have a human in the loop. So why does all this matter? Well, ultimately, AI's incredible promise isn't just about raw power. It's fundamentally about trust. If we can't reliably believe what an AI tells us, we're facing deeper questions about how knowledge, influence, and truth itself are being reshaped in our society. Hallucinations undermine reliability. You can't build critical systems on invented information. Deception undermines control. If an AI can strategically mislead, our ability to manage and direct it is compromised. Both of these threaten AI's credibility, not because AI is inherently untrustworthy, but because our current methods and incentives don't consistently prioritize truth and transparency the way they absolutely should. So as we continue to build and integrate these powerful tools into every part of our lives, we as leaders, developers, and policymakers need to keep asking the important questions. What incentives were built into this system's design? Is its output genuinely grounded in evidence, or is it just a confident guess? And if it tells me something that fits a little too neatly with what I want to hear, what's the underlying mechanism behind that answer? Thanks for listening to this episode of Quantum Logic. I'm Spencer Scott. If you enjoyed this episode, please share it with your friends and colleagues. And remember to stay curious and, as always, stay human. Bye for now.